This is a quick video tutorial on how to update the OpenIntro problems bank on MyOpenMath to include problems from the new 4th edition of OpenIntro statistics. First, log into MyOpenMath and select one of your courses, which was copied from the OpenIntro template. Once in, there are many ways to access the problems bank, but the easiest is to get there from the questions in an existing assignment. Scroll down to a homework assignment in any of the existing weeks in the course, click the settings gear icon, and click on the questions link in the drop-down menu. At this point, you can see the questions that are in the current assignment, and although we're accessing the questions bank this way, we won't be making any changes to the existing assignment at this time. What we will do is we'll scroll down until we see the potential questions heading, and I'll have you click on the description heading in the table to resort the problems by problem description rather than problem ID. If you scroll down in the table, you'll eventually land at a set of problems with a common naming scheme, OpenIntro statistics, followed by the problem number, and then in brackets some flags that describe the question a little bit, such as it's a multiple choice question, it contains an essay, it contains randomly generated parameters. You don't need to worry about any of that at this time. With any particular question, we can click the action button. I'm going to take a look at question 2.23. We can click the action button to either add that question to the current assignment, view the source code that develops the question, or to click the template button, which will allow us to create a new question without starting from scratch, just using the code from this 2.23 problem. Right now we'll view the source code. This problem is a number problem. So all that means is students will put in a numerical answer. You'll see two control boxes. The first box is where you'll put all of the variables necessary to define the question. At a bare minimum, you need an answer to be defined. This is the answer that MyOpenMath will look for when it's checking whether the student completed the problem correctly. You'll see the second variable, abs tolerance, which is defining a tolerance for acceptable answers. You can set this to be a reasonable number given the problem type. And then score method is single score, just saying we'll give a single score for the entire problem when all is said and done. The second box deals with question text. So this is essentially the question from the textbook, just copied into MyOpenMath. Within the question text box, you'll see that we've labeled a spot in the question for an answer box. This will lie on its own line beyond the question text. So that's a numeric answer question. If we go back to the question bank, we can take a look at question 4.22, which will be a multiple choice question. And so those questions are set up just a little bit differently. The question type again here is multiple choice. In the question control, we have to define the choices that the student will be presented with. This is just an array of possible answers, each particular answer choice surrounded by quotes. So here we've got 3 options. What I typically like to do is always make the first answer in this array the correct answer, because MyOpenMath will automatically shuffle the possible answers anytime a student logs in to complete their homework. So students will all see these answers presented in a different order. Once you've got the possible answers written down, you'll need to define what the answer actually is. Indexing here in MyOpenMath starts at 0, so I'm saying the answer is 0, the first element in this array. And again, we list the question text, providing an answer box where a student will select the answer. Let's take a look at one more type of question, which is a multi-part problem. And this is the type of problem we'll actually build at the end of this video. We'll look at 4.32. We'll click the action button, we'll view the source code, and now we see the question type is multi-part. You see the first variable here is answer types. This is an array with an entry for each of the questions that the student will be faced with. The entries in the array are the type of problem. So here I've got 5 problems that the student will be presented with. All of those problems are multiple choice problems, as denoted by the choices flag here. For each of those problems, again, indexing starts at 0. I'll need to define the possible choices that the student will be presented with, as well as the answer. So here, all of these problems are true or false problems, and then the answers, again, presented with the answer, and then bracket index denoting which question this answer belongs to. And again, down in the second box, we have the question text. Now that we've seen a couple of problems, let's actually build a new problem. So this is how you'll update the problem bank if you choose to participate in this crowdsourced effort. What I like to do is I'm going to open up OpenIntro Statistics, the 4th edition, and I'm going to identify a problem that I really like. So right now, the problem that I like is problem 5.14. Coupons driving visits. This is a problem asking students to construct a confidence interval. What I'm going to do is I'm just going to check in the 3rd edition of the textbook to make sure that this problem isn't there already. So I'm just going to search for the problem title. And that problem's not found here. So at this point, I can be pretty certain that the problem I'm interested in doesn't exist in the problems library already. So I'll go ahead and write it. But what I am going to do is I am going to look in OpenIntro Statistics for 3 for a problem that's similar to this one. And a problem that is similar to this one ends up being problem 4.16, which is the problem that's showing here. This is another problem asking students to complete a confidence interval for the age at which a woman is first married. And so let's go back to OpenIntro Statistics. We'll head back to the problems library. I know that problem 4.16 is already written into this problem library, and that's 4.16 from OpenIntro Statistics 3rd edition. What I'll do is I'll come across, and instead of viewing the code this time, I'd like to template the code. So now I am allowed to edit at this point. The description has been altered to say that this is a copy by test instructor, which is the name of the account that I'm using right now. I'm going to change the name of the problem, and I'd ask that you try to keep to this naming convention so that we're easily able to identify 4th edition problems versus 3rd edition problems. I'm going to start the description with OpenIntro Statistics, but then I'm going to label it 4th edition, and I'm going to say this is problem 5.14. Now I have the description updated. I'm going to want to change the use rights so that it's not only available to me, but it's available to everyone. So I'm going to allow use by all. This will be a multi-part question. I'm going to provide 2 numbers, which will be the lower and upper bound for the confidence interval, and then I'll also ask the students to select the correct interpretation of the confidence interval. So the question structure will stay the same. Obviously, the answers are going to change. I'll change the tolerances, change the choices for the multiple choice question, and then we'll change the question text. So I've done this problem already, and I know that the lower bound for the confidence interval is 0.2016. I'm going to leave an absolute tolerance of 5 thousandths. The upper bound for the confidence interval is 0.2694. And similarly, I'll leave an absolute tolerance of 5 thousandths. What I'm going to do is I'm going to leave the choices alone at this point because we haven't really looked at the question. I'm going to change now in the question text control box. The title for the question is 5.14, coupons driving visits. after the question title, so the strong tag is making sure that the question title shows up in bold. What we'll do is the easiest thing is just to copy and paste the question from the OpenIntro statistics text. And sometimes you'll have to do some quick editing because things don't always copy over correctly. So store randomly samples 603 shoppers over the course of a year. And so here's an error. We want finds that 142 of them made their visit because a coupon they received in the mail. Construct a 95% confidence interval. The sequence FI usually doesn't copy over very well. For the fraction of all shoppers during the year whose visit was because of a coupon they'd received in the mail. I'm going to say now, please round all proportions to 4 decimal places. Okay. So we'll change the question text now to estimate the true proportion of shoppers during the year whose visit was because of a coupon. They'd received in the mail. I'm going to leave all those controls the same. Interpret the confidence interval in context. I'm going to leave that the same as well. We've updated already the answers for the lower and upper bound for the confidence interval and those tolerances. So now we just have to update the choices available for the multiple choice problem. So let's say that the store management can be 95% confident that the population proportion of customers visiting the store because they received a coupon is within our confidence interval. We'll change the second option to say 95% of customers visiting the store because of receiving a coupon is within our confidence interval, which is totally a throwaway answer. And lastly, the store management can be 95% confident that any sample of shoppers would have a proportion of visitors whose visit is because of receiving a coupon be within this confidence interval. So at this point, I'm just going to change one more thing. This problem doesn't have the histogram image that the original problem did. That histogram image is down here, stored in a variable. I'm just going to delete it. And at this point, we can quick save and preview the problem. Everything looks pretty good here. We show answers. We've got the answers that we wanted. And now we can just save out the problem. We can return to the assessment. And somewhere down here, we'll see our problem, OpenIntro Statistics, 4th edition, problem 5.14, and now we are the owner of that problem, but everybody else can see it and use it. So thanks for agreeing to participate in the crowdsourcing effort for developing problems from the 4th edition of OpenIntro Statistics. I appreciate all the help you're giving. Thank you.